On page 11 of 5.3, we're finally going to get to put everything together that we've learned. So 2 pages ago, we learned how to find the LCD. The last page, we learned how to rewrite each fraction so it has the LCD. Now we're going to do both of those things after we factor, of course. Remember, factoring is always first. Anything that can be factored, you should factor. And then we're going to add and subtract the numerators like we did on page 1 of the 5.3 notes, and then we put them over the common denominator. And then remember, we always simplify at the end. So anything that can be factored, we factor. So notice the first step is factoring, the last step is factoring. So we should probably write that down. So factor numerator and denominator, and look for common factors. Numerator and denominator, that's what simplify means. Factor, numerator, and denominator, and that's what section 5.1 was about, how to simplify a rational expression. So they had us factor the numerator, factor the denominator, then we cancel common factors. That's how you simplify. Because anything divided by itself is 1, so we cancel those and replace it with 1. So that's what simplify means now with polynomials. And actually it means that with regular fractions too. I showed you that before on another page. But if we factor 6, we get 2 times 3. If we factor 9, we get 3 times 3. 3 over 3 is 1. So it simplifies to 2/3. That's exactly what this says. Factor numerator, we did. Factor the denominator, we did. Cancel common factors, there's our simplified answer. So we do the same thing with regular fractions. We're just now going to do it with our new rational expressions. Okay, so the problems are a little lengthy. I'm not going to kid you. They are lengthy, but if you just think of it as one step at a time, that's all I do is I just think one step. Okay, I know step 1 is factor. Easy. We just did a whole test on it. So signs are the same, both negative. Factors of 2 that add to 3 are 2 and 1, so y minus 2, y minus 1. Done. And I'm going to give you a little trick of the trade. This is probably the best advice I can give you right now. Anytime there's a minus sign, add the opposite and put it up there with that next number so you don't lose it. Because I know from experience, the most common mistake by students is they lose the negatives. And I see stuff is really, really light right here. So let's go ahead and write that in. So this is y plus 1. We'll get to it in a second, but I at least want it written in. I think it's because it's color and I don't have color ink in my printer, or I'm running low. So y minus 2. Okay, there we go. I think that's everything that was colored. Okay, so back to the beginning. Got a little sidetracked. So we factor this trinomial, double bubble, so leading coefficient's 1. This you should recognize as a difference of squares, because remember, 2 terms, if there isn't a GCF, can only be squares or cubes. GCF, look for first. But if there's no GCF, squares or cubes, and I can see it's squares. So we know that means the signs are different. 1 plus, 1 minus, and we do the square root. Square root of y squared is y, square root of 1 is 1. So now this is where our training from the previous pages on this section come into play. We learned that with LCD you write every factor you see with the highest exponent you see. So I just go down the list. I see a y minus 1. It's to the first here. It's to the first here. The highest power I see is to the first. Then continue going left to right. I see a y minus 2 here. It's to the first here. There's none here, so that would be like to the 0th. So I bring the y minus 2 down. I already listed this. I never repeat factors. And the other factor I see is y plus 1. It's to the first power, and it's to the 0th power here, so I bring down first power. So I wrote everything I see without repeating, and only with the highest exponents I see, but I didn't see any exponents here, so that's how I know there won't be any exponents here. So write everything you see without repeating, and with only the highest exponent you see. So then I look at this first fraction, I say, what is it missing to have this common denominator? Oh, it's missing y plus 1. So I multiply the top by y plus 1 and the bottom by y plus 1. Then I say, what is this denominator missing to have a common denominator? Oh, it's missing y minus 2. So I add y minus 2 here and y minus 2 here. So then I get 4y. You don't have to look at this step because we already added the opposite. So just go straight to here. 4y plus 4 minus 6y plus 12 all over, see the common denominator? Y minus 1, y plus 1, y minus 2, y minus 1, y plus 1, y minus 2. So they both have the same denominator. So now we're just like when we were on page 1 of this packet. When they have the same denominator, you add or subtract the numerators. Keep the denominators the same. So we did the distributive. We got all the signs correct. Now we combine like terms. Negative 2y is there, and then 4 and 12 gives me the positive 16. And students love to stop there because they're like, oh, this problem is long, I'm done. No, you're not. Last step is factor the numerators and denominators, and that's why I said in the last section, leave your denominators factored. So then all we'll have to do is factor the numerator. I see 2's common, but because the leading coefficient's negative, I have to take out negative 2. And when I divide each of these by negative 2, negative 2 divided by negative 2 is positive 1y and negative 8. Then I look for common factors. Anything common? Nope. So that would be my answer. So that's not so bad, right? If you break it down into little baby steps, just think one thing at a time. Factor. Then find LCD. Then make a common denominator. Then add or subtract. That's it. Just 4 tiny little steps that combine into one big problem. Okay, so let's practice our first one. So factor, nope. Factor, nope. Factor, yes. So I'm going to write 8x minus 2. It's going to stay the same, but I'm going to leave room to add in whatever it's missing. Plus x minus 6. And this can factor. It's a difference of squares. Remember how I said there's a ton of those in this chapter, so be able to recognize them quickly. 2 squares with a minus in between. And we add the square roots, then we subtract the square roots because we know this means the signs will be different. And then we have plus 2 over x plus 2. So now we look at the problem and we say, what would be the LCD? I have to write everything I see. So just go left to right and start. So x minus 2 to the first, x minus 2 to the first, no x minus 2. So the highest power I see is x minus 2 to the first. Remember what I said back on page 2, you never add your exponents. It's write everything you see with the highest power you see. I do not see a power higher than 1. Okay, then I keep going right, and I see an x plus 2. What's the highest power I see? Well, I see it once here, and I see it once here, so the highest power I see is once. I already have this, and I don't repeat factors. I already have this, I don't repeat. So there's my LCD. So then what I do, I write 3 fractions, all with a common denominator. And my goal is to make them all look like this. Okay, so they're all going to look like that. So now it's time to say what is missing. So I look at the first fraction, I say, what is it missing to make it look like this? Oh, it's missing x plus 2. So I add an x plus 2 here, and I add an x plus 2 here. So it's already written down there. Now all I have to do is distribute in the numerator. So that's going to be 8x plus 16. So first fraction done. Has the common denominator. Whoa, let's talk right. Has the common denominator and it has its new numerator. So then I say, what is this fraction missing to make it look like this? Oh, it's not missing anything. It already has the common denominator, so I bring the numerator down as is. So if it already has the common, just leave it. And then I move on to fraction number 3. What is this fraction missing to make it have this common denominator? And that would be x minus 2. And whatever I do to the denominator, I must do to the numerator. So now we have 3 fractions, and they all have the same denominator. That is our goal. So what's my new numerator here? 2x minus 4. Okay, now this problem is exactly like what you did on page 1 of this section. When the denominators are the same, you add the numerators and keep the common denominator. So we have 3 like terms here. So you might want to put a 1 in whenever you're combining like terms. It's nice to remember there's a 1 in front of that x. There's no negative, so we didn't have to worry about that. So 8, 9, 10, 11. So this would be 11x. Now we have to combine the constants. So we have 16 minus 6, which is 10, minus 4, which is 6. So that's a positive 6, because 16 minus 10 is positive 6. So 11x plus 6 over the common denominator, x minus 2, x plus 2. And remember, don't celebrate too fast. Now you look and say, can I factor? Is there any common factors? So can 11x plus 6 factor? No, it cannot. Nothing common. 11's prime. 6 only 2 and 3. No exponents, so no GCF. No exponents to make it squares or cubes. So this is one of the rare cases where you're actually done. It doesn't happen very often, so don't get used to it, guys. Okay, I think we have time to start one more on the next page. We won't be able to finish it, but we can at least start it, get a head start before the next video. This one would be an excellent one to highlight. I think both of the next 2 are really good ones to highlight, actually. So I know the ones on the test, I made them so they simplify. So let's do this. And let's do this to get ready for our next video. Okay, I think we have time maybe just to factor, and then we'll stop right there. So this first one is double bubble. Factors of 10 that add to 7 are 5 and 2. This says the signs are the same. This says they're both going to be negative. So x minus 5. Oh boy, I wrote another parenthesis, and x minus 2.